Hey, hi everyone. Welcome back to our new podcast. Today's podcast is very amazing and with a great personality. We have John sir. Hey, hi sir.
Hi, Akshay. Happy to be here.
Thank you so much for your time and accepting our invitation, sir. So, guys, this podcast gonna be a little technical in very detail because we have the expert who has a great knowledge on the blockchain and DHT especially. So I'll try to deep dive and try to get the as much as from this sir for next most probably 60 minutes. So, sir, without any delay, let's get started with you, sir. So, can you please help me with, sir, your detailed introduction, and then we'll jump towards your journey, sir. Over to you, sir.
Sure.
Yes.
Yeah. First of all, thank you, Akshay, for the invitation. It is indeed a great honor and pleasure to address your audience. Thanks to all those people who are listening. I am a professor in the computer science department at IIT Madras. I work in the area of distributed algorithms, and I also co-founder of the Cybersecurity Center at IIT Madras. So
Oh,
this is
nice.
my context, and within the cybersecurity context center, I lead the vertical on decentralized trust, and
Uh
that
huh.
includes blockchains. So that's the
Amazing.
context. Yeah.
Amazing, sir. Amazing, sir. Right, you are the professor in IIT Madras, so that's a itself is a honor for me to connect with you and talking. So now, sir, like so many people has a passion to be in IIT and do something, but so many people like me, I always has that, but I was not able to crack that. I was able to crack J, but not able to crack the advanced part. Okay, so I would like to know your journey, sir. How you started and how you land up into this IIT Madras. Yeah,
So I'm actually with you. I did when I finished my schooling. I didn't
yeah.
even know about. Well, I knew about JE, but I just didn't think it was relevant to me. So I didn't even take JE. Um, and I went through a private college here in Chennai, and then went to do my master's and PhD overseas. I went to do the master's, and then I realized that research was my passion, and unfortunately, I didn't have that inspiration here. It happened when I took some very interesting courses in theoretical computer science, designing algorithms,
Mhm.
and then I realized, okay, so this is very interesting. Um, Theoretical computer science has this ability to cut away the clutter and just focus on the core issues and try to analyze them and build algorithms, build theorems, proofs, and things of that nature. So that was a very exciting revelation. So that was the first time I started realizing that research is really what I wanted to do, and in
Okay.
particular, focusing on the foundations.
Hmm.
And that journey led me through the whole gamut of things in the world of algorithms.
Okay.
My PhD was in what are called online and optimization algorithms.
Okay.
Some from that journey, I went in. I After my PhD, I returned back to India. Worked in industry for a couple of years. I had 2 wonderful years at
Hmm.
Tata Research Development and Design Center, one of the TCS
Nice.
R&D centers.
Nice.
And so that was a great exposure into industry.
Hmm.
But my heart was always in academia. So with that, I joined IIT Madras in 2011, and
Okay.
I've been here since then.
Amazing, sir.
And along the way, somehow I got introduced to distributed algorithms. Within the
Okay.
world of algorithms itself, there are
Yeah.
many sub areas, and I got
Right.
introduced to distributed algorithms.
Right.
And ever since I got introduced to that, I kind of stuck with it. Uh, that's been the anchor. With that anchor, I moved here and there, but distributed algorithms is my core topic. Yeah.
Amazing, sir. Now, distributed algorithm is again your code, sir. You mentioned your PhD. So what was your core focus on your PhD times?
In my PhD times, it was this online algorithms.
Online
And an
algorithms.
online algorithm is not to be confused with something about going online and web related things. It deals with inputs not being available to you at the beginning. A classical algorithm has all of its input at the beginning.
Hmm.
Then it performs some processing on the input, and
Hmm.
then it produces the output. An
Right.
online algorithm is a little bit more realistic.
Hmm.
You get inputs in piecemeal. This is what happens in real life. If you are trying to do some stock trading,
Ha ha
it's
ha
not
ha.
like you have all of the stock prices in advance. You have
Right.
to, work
Wait.
with the current information that you have
Right.
and try to design algorithms that are optimal with the uncertainty that life has. And so
Right.
it's actually very a natural algorithmic paradigm. um, and that actually that paradigm continues to influence me even today, because a lot of my efforts are in the world of distributed algorithms. It's in the world of dynamic networks, and every blockchain you take is typically a dynamic network. The network is
Right.
never static.
Right.
Simple way to think about it is the following, right? If you think about the internet, it was formed in the 70s, perhaps, but none of the servers that ran the internet in the 70s are still there today. Uh,
Hmm. Hmm. Hmm.
the internet is a highly dynamic system, and still
Correct.
the notion of the internet has stayed persistent for so many years.
Huh.
And when you design an
Right.
algorithm like that with the dynamics, you have to realize that you have to design the algorithm with the now in mind, but keeping in mind that
Right.
there's also going to be a future. And so
Right.
this our notion of online algorithms kind of comes embedded into many aspects of life. Yes. So
Amazing.
so in that sense, I'm still kind of learning things more and more from that foundation that I built in my PhD days.
Amazing, sir. Amazing. So I have one follow-up question, sir, here. As you have a huge interest into the algorithm side, your research, you find your passion in, like, you are more into the academia and more into the research specifically. So what kind of algorithms, I'll come little later to the DHT because I'm putting a proper dynamic algorithms and for blockchain part section. So first I'm trying to create a base here, like what kind of algorithms you have explored so far which you find like a very fascinating in your journey.
Yeah, so I've explored algorithms in a variety of domains. Um,
Yeah.
until about a year or two ago, I was primarily just interested in theoretical computer science,
Okay.
and which means that I didn't have any specific application in mind that I was trying to solve problems
Mhm.
for. I was more
Hmm.
interested in solving problems because they were fundamentally interesting
Mhm,
and
mhm.
possibly useful
Hmm.
and challenging to work on.
Okay.
The possibly useful thing is helpful, but that was a sort of a nice byproduct.
Okay.
And this is a for good reason, because you don't want to always solve a problem that can be currently motivated. Sometimes you want to allow yourself to
Hmm.
solve problems that don't necessarily have some immediate applications.
Got
Publish
it.
the
Yeah.
algorithms, and then
Hmm.
the right people with possibly an interest in industry or
Ha
entrepreneurship
ha ha
take
ha
and run with it.
ha ha.
So the skills needed to solve an algorithm, analyze and solve an algorithmic problem may not be the same skills needed to take and commercialize it. And so sometimes best
Okay.
to just allow the right people to do that. So
Ha.
as a theoretician, I focus purely on algorithm design for the fun of it. And there was there are many problems that I really enjoyed over the course of time.
Okay.
There was one problem that actually was a lot of fun to work with, because it was also
Hmm.
quite challenging.
Okay.
It's this problem where let's say it's a thought experiment.
Yeah, yeah,
Let's say
yeah.
you have n bins. Okay, think of them as like little buckets, if you will, n of them, and you also have n balls in your hand.
Okay.
And one by one, you throw the balls,
Okay.
and each ball, when you throw it, it lands in one in a random bin.
Okay.
The question is, how is the pattern of the balls after you throw all of the balls into the
Okay.
bins? The reason this is interesting and important is actually this has a core impact in load balancing. When
Okay.
you talk about jobs arriving, and you need
Mm-hmm.
to you in a data center perhaps, and you need to assign the jobs to the
Different
servers.
data centers, right? Yeah.
Yeah, so or
Right.
even servers within the data
Servers
center.
within. Yeah. Yeah. Right.
So
Yeah.
you need to have the balance of across all of the available servers. And this thought experiment therefore became a very fundamental thought experiment. It's called the balls into bins.
Balls in the bins. Okay.
Balls into bins. And one thing that people realized is a very famous paradigm called the power of two choices. Studied in the 90s, a very beautiful phenomenon.
Mm-hmm.
If you just throw it randomly, it does get
Uh-huh.
spread evenly,
Uh,
but uh, the the most loaded bin,
hmm.
in the load balancing context, you don't want any bin to be overloaded. The
Right.
most loaded bin can have about roughly logarithmic of n number of balls in it. Okay,
Okay.
don't worry about it if you don't. That's it's not important.
I
But
understand that. Yeah.
yeah, right.
Yeah.
But here's the thing:
Huh.
the power of two choices is a slight tweak to the process. If
Right.
every ball you take, you before you throw it, you do one little test. You pick two bins at random,
Okay.
but before you throw it, you count the number of balls already in both of those bins,
Okay.
and always place the ball in the less loaded of the two bins.
Right.
This is a
Huh.
small change, a very
Hmm.
minor change. So think of
Hmm.
it this way: when a job arrives
Huh.
in the data center,
Right.
to randomly pick two servers and
Servers.
check, hey, how loaded is this guy? How loaded is that guy?
This guy.
Oh,
Yeah.
this is less loaded. Okay, assign
Right.
the job to this
Server.
server. That's all we're
Yeah.
talking about. This is
Right.
called the power of two choices because now you're creating for yourself two choices out of which
Hmm.
you're
Hmm.
choosing the better of the two choices.
Right. Right.
And turns out that if you do this, the most loaded bin or the most loaded server, if you will have an exponentially smaller number of balls in it or jobs in it. So it
Eh,
actually will
most loaded one will have a exponential less.
less because
Okay.
the height of the most loaded bin becomes logarithmic of n. Uh, so instead of log n, it's log n. So log n is exponentially smaller than log n. So that is this is something that people had already studied.
Huh.
And my then PhD student and we looked at this problem and we said, okay, this is great. Power of two choices is great, and there were some variations also.
Hmm.
We came up with another algorithm called the first diff. This is particularly helpful when you have lots of balls, not just n balls, but like much larger number of balls, which is what is really happens because if you have a data center with say 1,000 servers, typically the number of jobs that come in are like 10,000 or more.
Yeah.
Lots more jobs arrive at such a data center. The way to we, so the way we envisioned is this first diff algorithm. We kept randomly probing bins until you
Hmm.
find the first time there is a difference. Like you probe a bin, oh, it has 5 balls. You probe another
Okay.
one, it has 5 balls. And you probe
Okay.
another one, oh, now it has 7 balls. Okay.
Huh.
So you
Hmm.
the first time you see a difference,
Hmm.
you stop and always place the ball in one of the less loaded of the bins. Either 557 means you put it in the 5, or if it's
Okay.
554, you put it in the 4.
Okay.
Just these minor variations have some very
Interesting.
nice properties.
Yeah. Very interesting.
This is all before blockchain interests, but
Yeah. Yeah.
still
Yeah.
you can sort of see
Uh,
the little slight tweaks to the way we do things
right.
have tremendous impact on
Tremendous
on
impact.
the on the way
Yes.
data centers work and things like that. So
Correct.
that was perhaps an illustration of the way I approach things.
Yeah.
I try
Very
to keep the
interesting, sir.
algorithm as
Yeah.
as simple as possible, but
Huh.
all of the fun is in the mathematics behind the scenes.
Right. 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 Right.
Yeah.
Amazing. Amazing. Very well explained. and it's very curious as well at the same time, and impactful. True. So, sir, now let's move to our blockchain part. So, very first, let's start from here. How you explored the blockchain stuff first?
Excellent question. So, as I was working in this sort of distributed algorithms, I primarily worked on on cases where the network was fundamentally imperfect.
Okay.
Um, where imperfection could come in multiple ways. One way is that the network is highly dynamic.
Okay.
If you have a network of um, a, a 10,000 nodes, like in the Bitcoin context, for example, nodes often, go down, some new nodes come in. It's never
Right.
a static network. It's always a
No.
dynamic network.
Dynamic.
And we call that churn when nodes leave
Hmm.
and join. So
Hmm.
I spent a good amount of time working on churn.
Huh.
And I also spent a good amount of time working on one more uncertainty, which is called Byzantine fault tolerance, where some of
Byzantine
the
for yeah.
nodes become uh, somehow malicious,
Hmm. Yeah.
and because they are controlled by somebody that we don't trust,
Hmm.
and therefore those nodes start to influence the way the network behaves,
Right.
and we need to ensure that such influences are contained. The good
Hmm.
nodes finally should be the ones that drive the purpose and the intent of the network.
Right.
The
Hmm.
bad nodes should not be the ones that take
Participate
control
there.
of the network. They can
Right.
participate, you cannot stop the participation, but
Hmm.
they should not be the driving force. So, if it is, as an example, if it's a ledger that we are trying to maintain, the ledger should be maintained in the way the good nodes want it to be maintained.
Correct.
The bad nodes should not be the ones that control the ledger. So so these were kind of some problems that I was interested in, and I was working on it. And then at some point, I wanted to have some real world impact.
Hmm.
I realized that
Hmm.
I could keep on proving theorems,
Hmm.
and
Hmm.
I
Hmm.
can keep generating papers on the purely theoretical front.
Yeah.
But I also wanted to have some real world tangible impact.
Okay. Amazing, sir.
And yeah, and that's when the natural connection from my theoretical world to the
Yeah.
real world was
Real.
the blockchain context, because a lot
Amazing.
of the issues that I was studying
Hmm.
appears on the blockchain context. So as a
Okay.
result, that drew me into the blockchain space.
Great, great. So you have a
Yeah.
great start, and with the network, you get into it. You saw the multiple challenges, jerk, and all those things. So, sir, I have here one question. Then we talked about blockchain, right? So this question is from the application end. So as you know, there is a concept called Hyperledger Fabric, which says the DLT, distributed tables, distributed ledger, right? We have there and all those things. Is it possible for using this technology we can scale it to the 1,000 node? Like, so my always question is public blockchain is different. They have lot of number nodes and it is owned by different parties. So dynamically you can join and you can left it whenever you have the resources and all those things. But is it similarly possible for private blockchain as well to scale to that level? Like maybe 2,000 nodes or 1,000 nodes sort of things? Is it literally practical? Very first question.
Yeah, the practicality is probably the first thing that we should address.
Yeah. Yeah.
When it's a private or permissioned network, you
Yes.
have to have an understanding of the 1,000, 2,000 entities, and have some clarity on who's in and who's out,
Yeah.
and things of that nature. So,
Uh,
um, the practicality can be challenging.
right.
How
Okay.
do you govern
Huh.
such a large consortium of nodes?
Right. Right.
But if you can figure that out, I
Huh.
don't see an immediate problem with
Hmm.
maintaining a network of that many nodes. Of
Acha.
course, you may want to
Mhm.
architect it more carefully.
Hmm.
Uh, at that point, I would step back a little bit and ask, what is the purpose of that
Hmm.
network?
Hmm.
If the purpose of that network is only to provide, in services along one chain, uh, maybe we should architect it in one way. But
Hmm.
if it is, something that is going to service a whole ecosystem with multiple
Multiple
chains,
chain. Yeah.
then maybe we should architect it a bit differently, where maybe the 1,000 nodes can be split into appropriate groups. And so I think it's really a governance slash purpose, and all these things
Purpose.
need to be. I
Hmm.
don't think the science itself precludes us from having such a network. Of course, the communication overhead is a little higher.
Yeah.
So that's the other question. Throughput. What kind of
Throughput will
throughput
be
do you
less.
need?
Yeah.
Is that crucial at what level? And maybe then you can architect it in such a way that some nodes run the consensus, maybe other nodes play a slightly different role where they buffer the transactions and then feed it into the system. It's really an engineering question at that time,
Okay.
combined with what the purpose is, what your expectations are, and things of that nature.
Right.
And it's definitely something that we should see more and more, because always relying on completely permissionless systems is also not going to be a viable option for many of the
Th-
applications.
That's why I'm asking this question. So because now people are thinking like, can we use this uh permissioned network on a larger scale, right? So but they are think and here is one confusion around the theories, or we can say when we are building these products, specifically the blockchain network, there is a concept of organization and node, right?
Mm,
So many people will get confused with that. Is it one node is equivalent to one organization, or can we have multiple organization grouped together and we can call them as a peer? There is a concept of peer as well, which can
mm.
be an individual entity, because ultimately chain code is going to deploy on a peer and ledger will be owned by the peer, right? So architecturally, so what's your thought on that, sir? If someone want to architect any
Mm,
solution with
mm.
respect to this, so they should consider grouping it multiple their business organization into a one infra node sort of thing, or like what's your take on that? Yeah.
I'll have to have a little caveat here, because I'm not an expert in this specific
Okay.
thing. Because
Yeah,
it's
yeah, yeah.
you,
Yeah.
I've looked at typically the core algorithms, but
Yeah.
I can give an opinion.
Yeah, sure, sure.
If,
Opinion
take
only.
it
Yes.
for
Yeah.
what it's worth. I
Yeah.
always prefer simplicity in design,
Yes.
and sometimes the one node per organization is easier to work with. In particular, I don't know about the Hyperledger Fabric details, but I'm very familiar with another. I mean, I'm aware of it in
Yeah,
general. I'm
yeah.
just not into
Yeah.
the details of the architecture.
Yes. Yeah.
But I'm more familiar with the way another network works, the Hedera network.
Hedera. Yeah.
This is a permission network. It's a public
Hmm.
network.
Okay.
It's a global public network, and there we have about 32 or so number of council members.
Okay.
IIT Madras, my institution, is one of the council members.
Hmm.
London School of Economics is a council member. We also
Amazing.
have lots of companies, you know,
Hmm. Hmm. Hmm.
Google,
Hmm.
IBM,
Hmm. Hmm.
Apple,
Hmm.
the council members. Wipro is a council member, and so on. So,
Hmm.
Tata
Hmm.
Communications is also a council member. There was about 32 organizations, global organizations, spanning academia, law firms, tech firms, and banks, so on and so forth, that are members of the council. And each one of us runs one node of the consensus network.
Okay.
Um, and then there's also a notion called block nodes in that in the way Hedera architects the solution,
Hmm.
and we're also moving towards each of the council members operating one block node. Block
Hmm.
nodes are also open to other people. The consensus nodes are definitely restricted
Council
to
nodes. Yeah.
council
Huh.
members.
Okay.
And so the consensus mechanism used is called the hashgraph consensus mechanism, which was invented by one Dr. Lehman Baird.
Huh.
And that's a very, really nice consensus mechanism.
Hmm.
Very good latency, very good throughput, very secure, and it's stood the test of time.
Okay.
So that's something that I'm aware of. And in that context, it's nice for us to have clear responsibility of the one node that we are responsible for. So in that sense, sometimes simplicity helps.
Hmm.
Having said that, it really depends on the context. Maybe there is another context where it completely makes sense for
Hmm.
a collection of organizations to join together.
Yeah. Right.
It's the example, Ethereum.
Hmm.
And not everybody can afford the 32 ethers or whatever that,
No.
so you
Right.
really have
Right.
to pool your resources together.
Correct. Correct.
So
Correct.
it really depends on the
Con- Got it, sir. Now let's go a little deeper. First, I would like to talk more about this consensus mechanism you mentioned in Hedera, what we use.
yeah
Can you
yeah
explain me more, like what kind of consensus it is?
Sure.
Yeah.
It's very different from the proof of work, proof of stake,
Okay.
classic consensus mechanisms that you're aware of, and it's slightly evolving. But I will give you the more classic version that Dr. Lehman Baird explained in an early paper.
Yeah.
Um, so the way this works, the Hedera network works, is through three stages. You can view. One is what is called the gossip stage,
Yeah. Gossip protocol. Yeah.
so every node receives transactions,
Okay.
and these transactions are packaged in what are called events, and these events get gossiped around. Okay,
Okay.
events are nothing but they're similar to blocks, let's say, in
Okay.
the classical blockchain. So they're collection of transactions. You gossip, but when you gossip is just a way of getting information around. When you gossip in the classic blockchain, you have one hash pointing. I mean, like hash of the previous block gets locked into the current block.
Okay.
So here we do it a little bit differently.
Hmm.
The way the gossip structure works, when I send an event,
Hmm.
what looks like a block to
Hmm.
another node, that node will also create a block on its end, and that
Hmm.
block will have one pointer to its previous block as well as to the block that I sent to it.
Okay.
So there are two backward
Linkage.
hashes.
Yeah.
Yeah.
Okay. Okay.
So
Uh-huh.
this creates a slightly more complex structure called the hash graph,
Hash graph. Yeah.
which is that, and then trying to create an order out of that hash graph is an algorithm called the virtual voting algorithm.
Virtual
uh,
voting. Yeah.
Virtual voting. So it's a very nice, fascinating algorithm, and there's a nice mathematics behind it. There's a cock proof to show that that virtual voting algorithm is robust and secure and has all of the nice properties, and
Hmm.
it's really stood the test of time. So it's a very different algorithm,
Hmm.
and performs really well. So I think time to finality is within about 3-4 seconds.
Oh, it's too
So
fast.
it's
Nice.
very nice, very fast,
Yeah.
and the cost per transaction is also very low.
Okay.
It's about a tenth of a cent or something like that. It's pegged to the US dollar, the transaction costs.
Okay.
So it's actually very practically viable for a lot of application building. And I think the nice one more nice thing about this is they've open sourced the Hedera system. It's called the Hyro system. It's
Hmm.
under the Linux Foundation Decentralized Trust framework.
Oh,
Yeah, LFTT.
so is it under the LFDT? Oh, nice. I would
Yes,
love to
yes, it
explore.
is under LFTT.
Ah,
It's called Hyro. It's
Hyro.
Hiero.
Oh, yeah, yeah,
Hyro
yeah. I
project.
explored this one, but I didn't recognize it. It is a Hydra
Yeah,
stuff or not. Okay.
Hedera's open source
Okay.
version. Yes,
Okay.
yes,
Okay.
yes.
Okay. Cool. Cool. Cool.
So
Yeah,
yeah, so
love.
that's
Hmm.
what I really like about it is Dr. Lehman Baird did not just say, okay,
Hmm.
proof of stake is there, proof of work is there, let's just go with that. He actually went back to the drawing board, as they say, and reinvented a new and effective consensus mechanism, and
Okay.
that's actually quite helpful.
Amazing. Amazing, sir. So, I have one question here. As you mentioned, the transaction is a little cheap. It's like 10 cent or something like that. So,
Yeah,
do we
less than
have,
that, like what
oh,
a tenth of a
less,
cent.
less. Okay. 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 Okay.
Yeah.
Got it.
Yeah.
So, do we similarly in Ethereum we have to sign the gas? So, is there a concept of gas, or it is like there is a
Yes,
no? It's a concept.
it's very
Uh,
much
uh,
it is EVM compatible.
EVM compatible.
Yes,
Okay. Yeah.
except of course you have to pay for the gas using HBARs, which is the currency that Hedera
Huh.
uses.
Okay. So, is it already a chain, or like it's a public chain?
Yeah,
Then
it's
we can
public
build
chain since
application on
about
top of it.
2018. It's been
Ah.
operational,
Okay.
and yes, it's completely available. You can use it. Uh, it's just that, of course, it's a global chain, so
Huh.
you have to worry about the jurisdiction issues in case you're
Right. Right.
building applications specific to the Indian context.
Right.
Then you have to worry about the regulatory issues. But if you are working with a global client who's comfortable using it and there's no
Hmm.
regulatory barriers, I think you should definitely consider Hedera.
Love
Um,
to explore this thing. I'll
yeah.
check and try to build something on top of it. Now, want to go little back to our consensus layer. With respect to our earlier discussion, we had a discussion around CFT, cache fault tolerance systems, then BFT stuff, right? So when we talked about so raft consensus, right,
Hmm.
which we worked in Hyperledger. So any thought on that, sir?
Yeah, RAFT is a great consensus mechanism,
Yeah.
but and it does its job very well
Hmm.
for the purpose that it's designed for. And when RAFT or even the precursor Paxos, these
Paxos,
are all
yeah.
designed
Hmm.
for systems where you just want to work with others as you know that they don't have any ill intention, and you
Hmm.
are keeping your systems updated, and therefore there is no accidental malicious behavior sneaking into the network. So the problem though is
Hmm.
when you open it up,
Huh.
even ever so mildly, and when you and decentralization requires you to
Huh.
open it up, right? And when you open it up, and then you have to worry about potentially some node in the network or some fraction of the nodes becoming malicious or Byzantine, as we call
Byzantine.
it,
Yeah.
and
Yeah.
then you have to be careful. And then the one downside of these algorithms, Paxos, Raft, and things of that nature is that they are not resilient to Byzantine fault tolerance.
Yes.
So when you have such a situation where you may encounter Byzantine, behavior,
Hmm.
then you have to work with some other consensus mechanism that is Byzantine fault tolerant. All the public chains are Byzantine fault tolerant within assumptions that they make. So, for
Yeah.
example, Bitcoin is Byzantine fault tolerant under the assumption that the Byzantine I'll talk more about the Byzantine
Yeah.
adversary.
Yeah. Sure. Sure. Yeah.
The power that the bad guys have
Yeah.
is less than 50%. Like the computational power is less than 50%.
Correct.
Under that assumption, Bitcoin is Byzantine fault
Byzantine
tolerant.
fault tolerant.
Ethereum similar. If the amount of stake owned by the bad guys is
Hmm.
less than 50%, then you're fine.
Right.
In Hedera, for example, you have to ensure that less than a third of the nodes are are also at most less than a third are Byzantine nodes. Then again, Hedera will work and things of that nature. So every one of these things, there's a particular limit up to which they can tolerate bad behavior.
Yeah.
Um,
I think in raft also there is one limit. Let's say in 2f plus 1, like the formula is there, right? So
yeah,
f is number of faulty nodes we can consider if you
yes,
want to
that's
be
right.
a real one, right? So
Correct. That
similarly,
is true. Yeah.
yeah, there is the particle Byzantine fault tolerance consensus mechanism as well, which consider 3f plus 1, which Hyperledger
Yeah.
Indy has. So
I
they
see.
required minimum like 3f plus 1 number of total number of nodes should be in your network to considering f as your number of faulty nodes,
Yeah.
right? So
So
if yeah,
actually,
yeah,
it's actually at this point maybe it's worth talking about why those numbers come.
I was
Actually,
coming to that
very
only. Actually, I was coming to this part only now. Yes.
yeah. So the 2f+1 comes because you are trying to work with a majority, and so you're looking at a majority of the nodes being able to vote on something, and therefore you can progress. But if a majority of the nodes can somehow even become faulty. Here we're not even talking about Byzantine failures, just faulty. They cannot vote, and that voting mechanism will not progress. So Paxos, RAF, all of these, the moment the number of nodes is less than 2f+1, you will
Huh.
not be able to guarantee that majority vote,
Correct.
and that's where they stall.
Huh.
Whereas when it comes to Byzantine,
Hmm.
in the purest form, you cannot tolerate more than one third nodes being Byzantine. And it's actually really nice to see where that one third comes from. It's a simple thought
Yeah.
experiment.
Okay.
Think about this. Let's
Yeah.
say there are three people,
Mm-hmm.
Alice, Bob, and Carol, let's say, for
Yeah. Okay.
simplicity,
Yeah. Yeah. Yeah.
the usual characters.
Yeah.
Let's say that they're trying to they're I like to explain this in this one. Let's say they're
Sure.
going
Sure. Sure.
together on a on cycles. They're happily enjoying nature. They're going
Okay.
somewhere, and they
Okay.
happen to see a fork in the road. They're
Huh.
now trying to decide together whether to go left
Huh.
or whether to go
Right.
right. Right?
Okay. Huh.
And think about it. This seems like a simple decision. It's basically a binary decision.
Right.
But if you cannot even to solve some binary decision, there's no way you can do more complex decisions like maintaining a ledger or something like
Right.
that,
Right.
right?
Right.
So this simple binary decision, let's say that one of them is could be bad. So Alice, let's say, is good. She says, "I want to go left," and she says to both others, she says, "Okay, I want to go left." So
Yeah.
she registers her vote.
Good.
Bob says, let's say, "Oh, I would like to go right," and he registers his vote.
Right.
Now the power to rests on Carol, and
Oh
let's say
yeah.
Carol can be, let's say, it's
Malicious.
malicious.
Right.
That one person, what she does is the following. She will say to Alice, uh, let's go left. And to Bob, she'll say, I'll go right. And
Oh.
then what will happen is Alice
uh,
and Bob think that, oh, the majority vote is left or majority vote is right.
moves
And they
right.
will start pedaling in different directions.
Right. Right.
And Carol, being bad, has succeeded in confusing them. And
Confusing
they've
state.
taken
Wrong path.
inconsistent decisions,
Yeah. Right.
right?
Right.
And so this is the foundational sort of reason why one out of the three, when one of the three is bad, you run into these sort of issues in decision making. I'm simplified it quite a bit because the actual proof is much more complex and more
Yeah.
interesting, if you will. But
True, sir.
it gets the point across.
Anna, you mentioned it very correctly in a simplified way. So actually, it is complex, but this understanding the same concerns with this explanation, straightforward and pretty understood why this formula should implement it. That's why we have to give more number of majority. So the third person always not get the whole and sole power to decide the navigate the transaction altogether.
That's right.
Amazing, amazing, sir. Great, great, great. So now I have little another perspective here. I got the consensus part, algorithm part. We got to know that yes, Hedera is something which is doing much better. And considering this, if we governing the body in such way where we are making sure that my number of node is always satisfying the my formula like 3f plus 1
Hmm.
or 2f plus 1, then in that case I assume it's good to go with the these consensus as well. These consensus are pretty good in
Yeah.
terms of latency and
Yeah.
throughput as well. We can consider
Absolutely.
those.
Yes. Yes.
Right.
Yeah.
So in most of the use cases, whatever case studies I read most with respect to CBDC or maybe the different Hyperledger projects, they are
Hmm.
using the similar stuff for their
Quite
permissioned
possible.
blockchain,
Yeah.
right? Yeah, they are using it. So now the little shift from our topic on
Hmm.
the application layer. So many people says that there is no future of blockchain and it is the hype which was gone. So what is your take on that, sir?
Excellent question. I think
Yeah.
this requires a, a careful look. We need to step back and ask, what is it that blockchains are offering, right?
Hmm. Hmm.
And at the end of the day, blockchains are simply a trust layer in a larger application ecosystem. And when we hyped it out of proportion,
Hmm.
we ran into all sorts of problems because we created a lot of expectations, and
Right.
it looked like the world hunger would go away,
Yeah.
and things of that nature, and everybody would
uh,
get rich and things of that nature. So it's the hype doesn't help us. And so in some sense, I'm actually someone who entered into the field after the hype died down. So I
okay.
came in like 2022, 23,
Ha,
NFTs
ha.
and all of those things. People had
Gone.
already looked at it, and
Yeah.
people were fed up with it. And that's when
Right.
I really got interested in blockchains. And so
Okay.
I have a slightly different take.
Hmm.
As an academic, I'm more interested in understanding this notion of trust layer and
Hmm.
how it's like salt.
Hmm.
You don't, when you eat your food, you don't make a big deal about salt, but try eating food without salt, right? And that's
Yeah.
food is hugely enhanced by this little thing. You don't hype
Salt.
salt all the time,
Right.
right?
Right. Right.
And
Right.
it's the same way. We should not be hyping
Oh.
blockchains out of proportion. Blockchains
Right.
should be like the salt of
Salt.
applications,
Yes.
right?
Amazing.
And they
Yes.
should provide the trust layer.
Hmm.
People should be able to use their applications. They should be thinking about business. They should be thinking about how to run their business effectively, how that ecosystem develops.
Hmm.
And as in that ecosystem, there are going to be naturally interactions between multiple parties where you need some sort of an anchoring of trust. And sure, at that point, you use the blockchain just for that one aspect, anchoring of trust, providing this little bit of a sort of a sense of
Salt.
worry freeness.
Very
Yeah.
finished.
Oh, okay.
Yes.
The blockchain is there for us
Yeah.
to, make sure that, I don't get cheated. I'm able to, get the job done. And the
Hmm.
goal is to get the business up and going. That is the
Yeah.
focus. That should be the real driving force. So I
Right.
think now
Hmm.
people are understanding that, and without the
Yes.
hype, blockchain's actually getting finding its way in multiple application
Hmm.
contexts. People are
Okay.
not even using the word blockchains because that is having all
Yeah.
sorts of negative connotations with
Yes.
cryptocurrencies
Yeah.
and
Also.
things of that nature. At
Right.
the end of the day, blockchains are just a ledger
Ledger.
to anchor your trust on.
Correct.
And people use variations of things like the trust layer, the trust
Yeah.
infrastructure, and
Right.
things of that nature to kind of essentially refer to the blockchain aspect of the application stack. And that's fine with me. I mean, there's nothing much in a name. To
Hmm.
me, as long as we are able to provide the trust
Right.
anchoring so that
Hmm.
businesses can develop their ecosystem well, I think
Right.
that's what we need to be focusing on.
Correct, sir. Very well portrayed. And you have given me the very, new great perspective of looking towards blockchain. It's like a salt. I got it very correctly. So you don't need to think. I think due to expectations, high and heavy expectations, it got hyped. Immediately we should get a lot of money and a lot of wealth
Yeah.
in my pocket. So now people won't get that. That's why they are saying, no, this is not a real one, or this is a fake thing. And so many people took a disadvantage of it, like so many people try to make money out of it like that, due to cryptocurrency pump and dump game and all those things. So it spread lot of negative vibe. But as sir said, that's not the real situation now. Situation is changed, scenarios change, businesses using the blockchain but in different term to build their trust layer, to make sure that they will, whatever the contract steps, like cross border, this is very important. No one
Yes.
trusts nowadays in a different world, because everyone want to be very diplomatic, and with respect to their benefit they want to change their data anytime, right? So that's where the trust can come into the picture, that blockchain ledger can help to prevent your data in a immutable manner. That is where actually the real blockchain is. It's a core feature:
Right.
immutability, trust, security, transparency, audit trail, all those things.
Yeah.
If
And
wherever you
now with
Mhm.
the advent of AI, I think that there's
Yeah.
going to be a very significant need for
Hmm.
trust anchoring, because
Correct,
we are
sir.
going to simply hand over the keys to our purses and wallets over to AI systems for many things. And
Many
now,
things.
how do we anchor them and keep them within bounds and allow
Yeah.
them to do some things but not other things?
Not other things.
We want to be empowered to use AI to do
Right.
wonderful new things that it opens
Right.
up for us. But at the
Yeah.
same time, you want to do it in a trusted way. So I
Trusted way.
think the applications of blockchain in those contexts is going to skyrocket, and would I mean I don't see any problem with
Yeah.
use of blockchain and the adoption of blockchain. It's going to
Yeah.
grow with the ecosystem, AI ecosystem, the financial ecosystem, and
Right.
many other ecosystems. Uh,
Correct.
I don't have any worry. I think we just
Mm-hmm.
need to, have the right perspective, have the right architecture, and
Hmm.
focus on the business and focus on
Focus on
what
the
needs to
business.
get done. So,
Huh.
and then use this the blockchain service as needed.
Okay. Okay. Amazing. So amazing. So very well said. Now we got more relaxation. Like because last time, I'll tell you one thing. So I had a discussion with the Triple IT director, Hyderabad, right? Triple IT Hyderabad
Yeah,
director,
Professor
Sandeep Shukla
Sandeep
sir.
Shukla. Oh, yeah,
Yeah.
he's a great person.
So yeah, great person, great perspective. He was like, he's I think those guys are responsible for setting up Hyperledger Indy initially and
Yeah.
issuing the degree certificates. So I will
Mm,
also work in that same space, Hyperledger Indy. I was giving my perspective. Okay, sir, we can do that and all those things. No, it's little. He said simply straightforward. This is tricky. It's not going to solve the challenge of all
mm,
the blockchain and all those things because he loved the technology, but what key point he mentioned, it's problem about governance.
yes.
If you don't have a valid governance in the system,
Yes.
then it's no
Uh,
use of using blockchain.
correct.
That was his
Yeah.
concern. It's literally
Yes.
challenging sometime to maintain the same
Absolutely. Yeah.
network in the
Yeah.
different communities or maybe the
Yeah.
small communities. We have to trust the party who is controlling that particular node. That is very
Correct.
important.
Yeah. Yeah, I fully agree with Professor Sandeep Shukla, and I've had conversations on exactly this topic with Professor Shukla, and I think
Okay.
I
Hmm.
fully agree.
Huh.
Yeah, and I think uh, this is one of the things that, for example, Hedera
Hmm.
got it right in
Huh,
the
huh, huh.
sense that they have this very nice, robust structure called the
32.
governing council.
Yes, yes,
Um,
yes.
and I think it is important, even in, for example,
Hmm.
the Indian context.
Hmm. Hmm.
There is a need for some service within our jurisdiction.
Hmm.
This is something that I am actually passionate about, and governance is going to be the key here. You can,
Right.
it's easy to spin up a network and claim that you have a blockchain going,
Right.
but the way I look at it is the following. I mean, when you build the trust, you need to actually trust the people who build it for you, and there
Exactly.
must be a
Exactly.
structure around it. And if you
Right. Right.
again centralize it to one individual or one organization, eventually the organization's motives and interests are going to change. Just imagine, take any company. I don't want to name any companies, but take
Yeah.
any
Yeah.
prominent company 25 years ago,
Yeah.
may have started as a startup in some garage in the Silicon
Garage.
Valley. But
Yeah.
let's see what it is now. It's very
No.
different.
Yes.
I mean, if you had,
Yes. Correct.
if you trust any one company, they go through pivots, they go through changes,
Yeah. Right.
and the world is dynamic. And this is where
True.
my understanding of online algorithms kind of starts to
Ah.
throw my flags,
Dynamic.
right?
Yes. Yes.
You cannot make very long-term decisions based on one entity. So you really
Correct, sir.
have to have a robust structure around it
Hmm.
that
Right.
actually self-governs. And it's also true about politics. I mean,
Hmm.
there is a reason why we embrace democracy for
Hmm.
all of its failures, and the fact that we don't grow as fast as some other country that may have a much
Countries.
more authoritarian governance structure. But we trust our government because we have elected that government. We have a say in the formation of the government, to the extent that we can, right, with all of the limitations that it has. So I think that governance layer is extremely important.
Right.
And just thinking through that, and building an infrastructure, like say a trust layer for our countries, I think that it's going to be very important thing. And in fact, this is something where I've been thinking about. My group has been working. on the creation of an infrastructure, a national infrastructure for trust. So we are primarily, we as an academic institution, we want to focus on the thought leadership, but
Right.
really the governance should be something that people see the need for and actually join forces with us
Correct.
and help build. So looking
Yeah.
forward to how things grow. Maybe we can have a follow-up podcast at some point where I talk
Sure,
specifically about
sure.
that. Yeah.
Yes, sure, sure. We should. And here I have one interesting question based on whatever we are communicating now. So, what do you think? Like, we are talking about politics, we are talking about democracy. It comes from the election and voting, right? So, in India, election is always cautioned in each and every time. Is it election fair? Another party always trying to question that. Is it literally a pure demographic or a number of factors there? But is it really possible? I just want to understand your opinion, sir. So, is it literally possible to do the election in a decentralized manner by any chance?
It
What
does
do you
happen
think?
to a large extent in a decentralized manner, right? I mean, the each state government it takes responsibility to conduct elections, and so in that, so there is no way one. I mean, I'm sure the election commission definitely has some mandates, and but then the execution is definitely very, very decentralized, and reliance on so many individuals. And to do things. So it it does work in a decentralized fashion. Let me
Okay.
step back. The
Okay.
one issue that you talked about is the questioning of whether an election is happening in a fair way without
Yeah.
corruption.
Right.
Uh, I don't know the answer to it, but we should never stop questioning.
Yeah.
Because the moment you start becoming complacent in any
Hmm.
of these sort of governance structures, if you start becoming complacent about it, that's when the issues happen. Even
Right.
if it is perfect, we should always keep
Hmm.
questioning. Hey, why was this done? Why was this discrepancy there? And things of that nature. Uh, uh, Questioning should not stop.
Hmm.
At the same time, it should be you need to also get the job done. You cannot let the questioning completely derail the election
Main.
or
Yeah. Right.
yeah, the
Right.
purpose of
Purpose.
the election exercise, right?
Correct.
So and thankfully I am not in politics. I'm sticking to my technology where I can prove theorems and I can
Right.
actually have some sense
Right.
of control over
Yeah.
this thing. So I don't want
Right.
to go into politics too much because that's not my cup of tea. But
Yeah. Yeah.
I certainly feel that questioning it is important, and that's true even in a purely technological setting.
Right.
Questioning, hey, why is this designed this way? Why are you architecting it this way?
Right.
Which consensus mechanism are you using? Why are you using it? These questions need to be asked, and
Right.
the hard questions need to be asked, and the hard questions need to be addressed
Addressed.
properly.
Right.
So, uh, but but I'm a little bit skeptical about using blockchains for elections, if that's
Hmm.
kind of what you were hinting at.
Yeah.
And the main reason is it depends on how the blockchain is used. But if you're
Hmm.
going to use it to actually
Hmm.
record the votes,
Okay.
just because feel like it's a secure ledger,
Hmm.
my worry is that there is this. I'm not remembering this phrase. There's some people can actually the blockchain is having a permanent record of some of the activities,
Right.
and maybe it's cryptographically hard to penetrate right now,
Penetrate. Yeah.
but 10 years from now maybe there are some tools
Yeah.
to
Two.
crack all of these things,
Right.
and then
Right.
I worry. So
Hmm.
we should be careful not to put such a permanent record of our voting activities on a
Hmm.
blockchain. So I
Okay.
think we need to really architect the voting mechanisms a bit differently, so
Hmm.
that there
So
is
future proof.
deniability.
Yeah.
We don't
Yeah.
want we don't we don't have to worry. I mean, the citizens should not be worried about uh, their vote preference being leaked. So
Okay.
it's a much harder problem. I don't work in that specific area, so I don't want to comment much more.
Yeah.
But I
Yeah.
just want to recognize the importance of the problem and the value of that problem,
Right.
And the skepticism that I share in terms of using blockchains, I'm not saying it cannot be used at all. I'm
It's
skeptical about
little skeptical about it. It's
it. Yeah,
worry point because quantum is coming soon. So many people is talking about
exactly.
quantum, right?
Yeah,
So it
yeah,
can be get cracked very easily.
yeah,
That's the biggest, worry most of the startups and businesses also have. Like, okay, they are using blockchain and all those things. Even cryptocurrency has a biggest threat with,
yeah,
with respect to quantum only. If
yeah.
quantum is ready and if once it's get into the market, keys are gone. That it's not secure. Then they'll simply
Correct.
hack their
Yeah,
keys and withdraw their fund from their wallet. That's it.
yeah.
Okay,
So
got it, got it. Very well said, sir. So I think we are just close to our 60 minutes as well. So it was very well, so very well insights shared by you. So I would love to understand one more thing. So this is my personal and curious question. How your day look like at IIT Madras, sir?
it was very crazy. Yes,
Yeah.
I must say, I mean, like
Huh.
the people who have much more challenging schedules to deal with. For
Haha.
example, people who juggle administrative duties
Right.
and academic duties, as well
Huh.
as other things. Um, I personally, uh, I mean, I run a lab,
Yeah.
so there are about 10 or so people who are, working on projects with me,
Okay.
and so I need to make sure that I'm able to give some amount of time to them. I need to, get some funding to make sure that they are,
Okay. Yeah.
they can get paid, and
Yes.
they can eat and all of that.
Yeah.
Apart from that, I have to also do my teaching, my own research, and in my
Huh.
case, it's somewhat, that is one part that's challenging because my interests are also spanning both applied as well as theoretical computer
Oh,
science.
oh my
So
great.
I've not stopped my theory research. I still have some amount of theory research that is happening as well. So that
Amazing.
and for that, a lot of times I connect with my collaborators late at
Haha.
night because they are based in the US or Europe or something like that. Plus, my
Amazing.
day is working with my students in my research
Okay.
group in my lab. So it kind of it spans through the day, and
Uh-huh.
the nature of the work changes. I start with teaching in the morning,
Uh-huh.
typically in the afternoon. It's probably meetings either with
Yeah.
potential organizations that are interested in working with us in some way, or my
Uh-huh.
students or
Hmm.
things of that nature. Then I take a break. Spend some time with the family, and then post
Amazing.
dinner I start
Uh-huh.
some meetings with my collaborators,
Collaborators.
yeah, elsewhere, and then and then rinse repeat every day. So it is a
Amazing.
but I
Yeah.
like
Yeah.
everything that I do. It's just that sometimes it gets a lot of a bit busy, but I
Busy,
enjoy
busy schedule.
every but I
Good,
enjoy
good,
every
good.
piece of it. Yeah.
Good, sir. Good, good, good. Great, great, great. So love to meet you in person sometime and talk more on the same, sir. Let's see,
Likewise.
let's see. Yes, sir. So, again, sir, one last thing. Uh, I have here one question. So this could be, let's say, if you start in 2026, if you're starting your career, I want to understand your opinion or your suggestion. Just think you are starting your graduation career in the 2026. So what would be your thought process or what you could do at this point?
Excellent question. I think this is a very, very important question. Uh, I would want to make sure that I am strong in the foundations.
Okay.
There's a lot of people who, uh, you know, who are trying to build their career around AI right now,
Right.
especially, all of
Vibe
the
coding.
why, yeah,
Yeah.
exactly. And that's great. I don't personally
Hmm.
have anything against it.
Hmm, hmm,
I
hmm.
just worry that dependence on AI tools
Hmm.
uh, without the right foundations, that can be devastating. Uh, Ultimately, AI should be in our hands
Hmm.
to do what we want it to do. We
Right.
don't want a dependence on AI to the point where it becomes a crutch, and
Hmm.
without it, we are completely at a loss.
Right.
And when that happens, what happens is that your life and your career is completely controlled by that.
Hmm.
And what recently I had a very nice conversation with a former student of mine who now works with at Microsoft in Seattle. He was here for a vacation, and he said that at his stage, he graduated in 2014 or so. So he's now a senior manager at
Yeah.
Microsoft,
Hmm.
and he said, because I had good foundations. I didn't have access to AI when I was learning all of these things.
Hmm. Hmm.
I'm able to use AI very well, and my productivity has gone up.
Huh.
But he's hiring people who are
Hmm.
now currently graduating who sometimes don't pay attention to the foundations, and
Correct.
then it looks like they're very good at using AI, but
Yeah.
clearly their productivity is much lower.
Lower.
And so to leverage AI,
Hmm. Hmm.
you really need to be having strong foundations, and you
Hmm.
need to rely on your own creativity. I mean, AI
Yes.
is just going to suggest things that look very creative,
Yeah.
but at the end of the day, you have to take responsibility for your own creation.
True, sir. True, true, true. Amazing, amazing. Very well said. So, what I can take out of from your suggestion, sir, ki we have to start focusing on our fundamental concepts. Whatever we have to learn in the academics, that is must to have. Not just bunk your classes and start doing the vibe coding. That
Yeah.
is not completely correct.
No,
You
that will
must
not
need
sustain you.
that
Yeah.
won't sustain, and you must to have the fundamental knowledge properly. You have to do the proper data structure, oops, whatever concepts we
Yes.
have there,
Yeah.
architecture and all those things. It's important because now
Yes.
people student has that myth, like what I see, people are simply saying, why don't we even need the classes? People has that kind of thought process. AI is there, why we are learning everything? AI can build for me, so why should I learn coding, or why should I learn the engineering part? I can simply drop my college or something like that and start building things by my own. I can simply command it and they will do it. But that's not the real thing. At one time, you'll fail everything. If AI is not
Yeah.
there for 1 month, what you will do then?
Yeah. Or
Everything is
if
gone.
or if AI makes a fundamentally bad decision and you're
Yeah,
not able to
judge
identify
the.
that,
Yes, yes,
you're going to lose your reputation completely. You will try to put out
completely.
a product that is completely bogus,
Yes,
and just
yes,
feels all right just because AI took
yeah,
care of all of the bells and the whistles and everything. And then the
yes.
fundamentals are bad. That's you completely lost the plot at that point,
Plot.
and so it
Correct.
can be pretty devastating. So that's not
Yes,
ignoring the foundations is never a good idea. I would
not a good idea.
strongly advise that,
Hmm.
you know, you can use, for example, you can use
Hmm.
AI to help you with the foundations, right? You can
Yeah,
actually use AI to learn
yes.
and be a partner with you. It's important to, I'm not at all against the use of AI, but each individual has to take responsibility for whatever creations that they have. Like
Yeah.
whatever creativity that you have, you need to be responsible.
You need to be responsible. That's a skill. You must have that creative skills here, not dependent on someone. So that your creativity should not rely on AI. If you have AI, then only you are creative. No,
Right.
you are
Yeah.
creative. That's why you are increasing your productivity using AI. That
Yes,
should be the case.
absolutely,
Right.
absolutely. You
Yeah.
nailed it. Yeah.
Amazing. Amazing, sir. Perfect.
Mm.
So I think we have got your time, right? So it was great talking to you. So I loved it. And it was a very valuable conversation. And I would love to host you multiple such valuable sessions, sir.
Sure. Yeah. Happy to come on board.
Yes, sir.
Akshay,
Yeah.
I really enjoyed this discussion as well.
Thank you
So
so much, sir. Thank you, sir. That's much
wonderful. Thanks.
appreciated.
Yeah.
Much appreciated. Thank you so
Thank you.
much, sir. Yeah. Bye bye, guys.
Bye.